Hello and welcome to Computer Science 1100 at Carthage College. This class is called Introduction to Computing. We will be using the programming language Python, and in this first collection of videos, what I'm going to do is give you some of the history and vernacular of computer science. I know when you're first starting out as a computer programmer, all of the different words can be overwhelming. So we're going to go over some history and understanding of how computers were developed, some of the terminology that you're going to hear, and then we're going to cater all of that information to the language that we'll be using throughout the course, which is Python. I'd like to start out by telling you just what I want us to be able to do with this course and what the benefit is of learning how to program computers. And I get to give you one of the most useless answers there ever is, which is you can do pretty much just about anything that a computer can run if you can learn to code. So you can make apps if you want, you can make little programs for yourself, you can automate some tasks that you find trivial. There's a lot of power in learning how to program a computer. We just have to get practiced in that art. Specifically in learning the language of Python, we're learning a very popular, very powerful language that is used by Google, that's used by Instagram, and that is used by Spotify, amongst many others. Another thing about Python, if you're interested in the new subject of data science, Python is a very powerful language for doing data science. And in this particular class, I'm going to focus on three main types of projects that I'll give examples of on our first day of in-person instruction. The types of projects that I'm going to be doing examples of are practical projects, playful projects, and what I'm calling pointed projects. So the examples I'm going to be using is something like a mortgage calculator. Say you want to buy a house and you want to make a payment plan that might be a little bit different from the bare minimum. It'd be nice to be able to look at all of the finances of that, and a computer program can do that in an instant. And in creating your own program, you can tailor it to your very specific needs. For something a little bit more playful, I want to show you how to use a graphical feature of Python to create spirograph designs, which I think are just fun. There are other things you can do like creating games and apps. All of those are things that I would classify as playful computer projects. And then I want to talk about something that's maybe undervalued but is really important to me, which is a pointed project. I want you to take some sort of issue that's of particular importance to you. Maybe it's a problem in your major, maybe it's a senior thesis, maybe it's a problem of social justice in the world. And I want you to see how you can use computer programs to help you study that object of importance a whole lot further. So the example I'll be giving in class is how can I use Python to determine sexism in movies. Let's get started a little bit with our history and our vocabulary. In order to understand the programming language of Python, which is something called a high-level programming language, we have to understand what came before it in the history of computer science. So when you think about how does this actual physical object of a computer understand the things that I'm typing, the computer reads something which is called binary code. So these really, really, really long sequences of just zeros and ones. However, those sequences of zeros and ones are not random. They're encapsulated into little bits, and each bit of information is telling the computer a specific instruction. So it's kind of like driver's license codes, if you've ever studied that before. What I have over here on the right are a handful of different states, and then a little key that says when you look at a driver's license number, there are little chunks of the numbers, like the first 3 digits, that are somehow encoding maybe your name. And then the next 3 digits might be encoding your address or your city, and so on and so forth. And there's a system for that, but different states use different systems to encode the information. And a similar thing is true with computers. We've got these really long strings of zeros and ones, which is binary code. And then the order in which that information is encapsulated and what those different encapsulations mean for the computer is called machine language. And all of that is very specific to the computer that you're working on. Different computers at different times and in different countries will have different machine languages, just like driver's license codes. If you take a look over here, you can see that Delaware encodes your address first when looking at your driver's license. However, a state like Wisconsin encodes your name in the first couple of digits. And so just like these driver's license codes that are encapsulated chunks of numerical information, the same is true of machine language, and it does vary from computer to computer. You can imagine being a person programming and having to learn machine language. You would have to learn this very long string of zeros and ones to just learn basic commands of the computer, and you would have to memorize the order in which to do them. And all of that might be specific to just this one machine and could change as soon as you start working with a new machine. This wasn't a problem in the time when computers were incredibly rare and you might work your whole life with one computer, but this is a major problem in the modern era. So what happened is that people stopped doing that. People were making mistakes, it was getting really hard, and so something was created called assembly language, which was kind of a hybrid. There would still be these long strings of zeros and ones, but computer programmers would say, okay, I'm working with this machine, and in this machine, one thing I do all the time is add. And whenever I'm working with a chunk that is adding, it's going to be something like 100101. And so I will write, when I'm writing my computer code by hand, I will write add, and then this long sequence of zeros and ones, which would be the continuation of the code for other things. So this was helpful in preventing errors and shortening the code and being easier for the programmers to read. It was kind of like when you go to a grocery store and you find somebody who's memorized the different produce digits. It says, oh, apple, that's 4681. It was kind of like that, but it was still really the computer programmers coming up with a shorthand in their quest to learn machine language. And because assembly language depended upon machine language, it wasn't universal. It still depended greatly on the machine that you were using. Where we're going to be getting started when we use Python is with a high-level programming language, thankfully, which is this invention of saying, no, we shouldn't be spending our lives memorizing machine language. We should be writing computer code as close to our natural language as we possibly can. For me, my natural language is English, so I'm going to use that as an example, but you can program in different languages as well. So high-level languages are modern programming languages that are meant to read a whole lot more like how you would speak or how you would give directions in your natural language. And an example of what that might look like is over here in the graphic on the right. So instead of using something like machine language, which is all of these zeros and ones, or assembly language, which would be lots of zeros and ones with just the word add or sub thrown in there every now and again, it's something that reads a whole lot more like English. And this is also standardized across computers so that you can use a programming manual or the internet, and you could learn about Python, and we can all learn, and we can all run our code on our different computers, run exactly the same code, and it will always work the same, no matter if our computers have a different machine language or not. So that's a really powerful and super important technological advantage that we'll talk about a little bit more in the next video.